Hello everybody and welcome to the first talk here in Hall 3. Our speaker is Swally, and in his talk he will address the history, the programming details and the hardware internals of one of the first game consoles on the market, the Atari 2600. Give him a huge round of applause. Here's Swally.
Hello. Hello. So this is what I want to talk about today, the Atari 2600 video computer system. Yes, it's really called that way. So I'm going to talk to you about the history, the hardware, and how you can write programs. Some first steps on how to get there. So why do I want this talk? Well, the idea came from two different aspects. One was Michael Stahl, who inspired me to do a talk about retro computing when he did his talk about the C64. And the other one is, why did I choose really the Atari? Because it is very well documented, the CPU, and the video chip is as well, and the video chip differs from anything else that you've got in any other hardware or any other gaming console. And this is the main cause. So, first of all, I got to thank you to all these guys. They did the pioneering. I just took on of their work and did the talk. And there are a lot of sites concerned about the varying aspects of hardware, video gaming in general, and specifically even on programming on the 2600. So let's start with the history. Short about Atari history. Atari was founded by Nolan Bushnell and Ted Gaffney in 1972. The first, it was founded because they wanted to produce what is now known as Pong. The first, this is recognized as the first worldwide popular video game, and though it's not the first at all. The same goes for the Atari. It is also thought of as the first gaming console for home, but this isn't. There was the Fairchild Channel F was further, but this was the one that really got the huge success. Between 1972 and 2001, Atari had an arcade game division, which was the basic, or one of the main fields of industry where they worked in. And some of the games were also implemented for the Atari 2600. So let's start with the design history. Well, their first release was a home version of the Pong game, which was a success and a failure both. It was a success because it was the first game that really got into, first video game that got into people's homes. But it was more a failure for Atari because it was cloned very fast and they couldn't get much money out of it. So in 1975, they decided to produce a home game console based on a programmable design using a CPU. They codenamed it Stella after the bicycle of one of the engineers. And when they started designing, three processor designs were considered. The Intel 8080, the Motorola 6800, and the MOS 6502, which was an independent company once the design started, but between that and the release of the Atari, the whole MOS company got bought by Commodore so they could produce the PET computer and later the C64, VIC-20, something like that. And one of the key issues, what they wanted was it should be really cheap, so that a lot of people who are not into video gaming would also consider buying one. So the basic design was set up in 2 days with the core team of the engineers together with Chuck Peddle of MOS. He was the man who designed the 6502. And both the CPU and the chipset were off-the-shelf components. If you take a look at nowadays consoles like Wii, Xbox, or the PS3, all are custom designs. So this is, back then it was off-the-shelf components. So, but the main thing, MOS got the deals because they were significantly cheaper than the others. The first offer was about $15. Atari sank the price to $12, whereas the competition got them to, or wanted to have $150 to $200. The guys at Motorola were sure that they wouldn't have got the deal because they were a bit cheaper than Intel, and they didn't know about MOS. So a week after they learned that they didn't get the deal, they sued MOS for patent infringements. But what still needed was the chip responsible for video and audio. There were no off-the-shelf components available at this time, so J. Miner designed one. J. Miner is also known, or better known, as the father of the Amiga. And he did it using breadboard technology. We have a picture of that later. And it was a rather expensive design phase because it was very tedious work to do. And it took quite a lot of time. But when the finished design was transferred into a chip, this resulting chip was easy to produce. And it was named TIA, short for Television Interface Adapter. So this is what a breadboard looks like. And this is just a binary counter. So imagine if you want to put a whole video chip on this one, that you really got to need a huge size of this. This is what the finished die looks like. And Atari is a part of pop culture. Though they were not the first on the market, this was the Fairchild Channel F, but they were the first that achieved really broad distribution. And it was released in 1977. And after the first release, the PCB design and also the casing was constantly redesigned, but the last version is still 100% compatible to the first version. And I knew back in the 80s, Atari was a synonym for home gaming. I knew back in the playground, when I was a kid, there wasn't, do you have a home game console? No, it was, do you have an Atari? And it was discontinued at the end at 1991. So it was in production for more than 14 years. And this is the longest, this is a console that remains the longest in production. There are about 500 games that were programmed. If you're going to count in bootlegs, NTSC PAL conversions, stuff like that, you can get estimated to over 10,000 different modules. About 7,000 have been counted by one website. So this is what the first Atari looked like. There you see the module, you're going to plug it in there. And this is called as the 6-switch model because there are still some difficulty switches on the front. In the next revision, they did not get moved away because it is still 100% compatible, but they have been moved to the back, which is better to see by the next revision, which is just another different color. So you can see there and there the difficulty switches. This was the last one of the original Ataris that was produced. If you want to go and code on real Atari hardware, I suppose that this is the console that you're going to use because it is technically the most advanced and it's really easy to modify for an AV output. The others still need some more. But this is for about parts 2 to 3 euro. You can build your own AV output. This is the Atari Flashback. So when Retro really got on the way, Atari also wanted to make some money of it, and they put a whole series of Flashback consoles. This is the Flashback 2 Plus, which differs from the original 2 just by a different game selection. The Flashback 1 was not really an original Atari 2600. It was a NES system on a chip design where the games has been ported to. The Flashback 2 is an ASIC design of the original hardware, And the Flashback 3, which is gone on the market this year, is an ARM-based computer which just runs an emulator. So, back in the days, there was this green meadow where they're going to put on new games. So where did they get their inspirations from? Well, first of all was to port some analog games, call them, something like chess or checkers, and also there was an attempt to port the video pinball. So this is what these games look like. Sports were a very nice thing where they got their ideas from, and most of the sports have been implemented more than once. So there's boxing and real sports boxing, real sports soccer and Pelé soccer, and so it's nice to compare them. We have that on the next slide, and probably the biggest selling title there was Decathlon, the Real Joystick Killer. So here we have basketball and soccer in the different year. So this was really from the early days. The double dunk is more sophisticated, but the most interesting part is compared to soccer. On the soccer, on the Pelé soccer, you have 4 players, three players and a goalie, and the field players are always stay in this formation, so you move all of them at once. 6 years later, they got more sophisticated. The other players were controlled by the computer. You just controlled 1 player, and there were 6 field players and 1 goalie. So another huge origin of games was to franchise other titles like movies or cartoons like Spider-Man, and even something like the Muppets. And the first Star Wars video game was for the Atari 2600. And but there's no roundhouse kick. I tried it, I couldn't get it. So this is what the games look like. This is the first Star Wars title. So you're going to play your fighter against the AT-AT, Spider-Man, Smurf, and this one is Rails of the Lost Ark. Though it doesn't really look like much, it's one of the best adventures program for the Atari, and it's still a fun title to play today. But the biggest section was to port arcade games, but it was not really porting, but it was just a re-implementation of the original game idea. So let's just compare two games. I can tell you one of these conversions sucks, in my opinion, and the other one has really gotten very well. As I put on the slides, I say from the view of the games, you really couldn't tell which is which. But Donkey Kong, in my opinion, sucked because the original has 4 levels, and the Atari clone only has 2, the first and the last. And Popeye includes all 3 levels, and they are also very fun to play. But this is the part you really want to get an Atari for today. These are the original titles. They are really invented for the Atari. The most important part there is you have the most original titles were just another space shooter and something like that, but there were really some really nice pearls in there. Haunted House is a nice adventure survival horror game, is it also called. Pitfall is a classic, and Adventure is the one I'm going to introduce you in depth to. So this is what these games look like. About Yard's Revenge, there's a nice thing to know. This energy barrier you have there, which blocks your shot, the developer wanted to have some random data. But space in the cartridge was really short, so what he used as random data is what you see there is program code used as a table. So let's take a look at adventure. Why did I choose adventure as an example? Because it's the ancestor of all action adventures. So when you play Zelda, the original one was for the Atari. It is still a fine game to play. Okay, it will not take you as long as Zelda to come through. A skilled player can do the easy version in less than a minute, and the more complex. But this is just an introduction. The real level can be the real game setting can be done in about 5 minutes, something like that. But till you get to that point where you can do it in 5 minutes, you have still some things to learn. So it will get you, for the first time you get it through and think you're done. It is about an hour. The original author of this game had put on a small website about this game, where he also includes slides for a lecture he gave about this game and the Atari development in general. So, how do you play it? This is you. So, you start as an adventurer in front of a castle, and your job is to bring the enchanted chalice back to that castle. For this, you have a world consisting of 29 screens, like the first one that you saw. There are 3 castles, 3 mazes, consisting of several non-linear screens. So when you move out to one level, you can get into the same level as you can get if you enter to the right. So it's really you've got to learn your way by this turn, that turn, and not by just thinking as just as a plain area. There are several connecting rooms, like forks, so where you can get either to the maze or to the castle. There are some dead ends. Some of them might contain objects that you need to solve your quest. So let's take a look at these objects. All objects interact by overlapping, so touching. This was something very new back then. We've got 3 dragons who chase you. This one is the real enemy. Because it moves your objects away, you can carry only one. And so if you put it somewhere, it steals it from you. So maybe the sword is gone when you want to fight a dragon. You've got, for each of the 3 castles, you've got a key. A very nice drawn sword to kill the dragons. This is something really cool. This is a wall where you can cross through, a bridge where you can cross through horizontal walls. The magnet to attract objects. This is also something very nice. This is a workaround for a problem you've got. You can drop some of your objects inside a wall so that you can't get them anymore, or the bat can do this. So you gotta get it out there somehow, and this is why Warren has implemented this magnet to attract the objects. And of course, you've got the enchanted chalice. But the coolest thing about adventure is there's one more object. It is 1 pixel in size and has the color of the background. So if you drop it, it's really hard to find. It's hidden in a room that's only accessible using the bridge. So in the normal gameplay, you even wouldn't come to this room. When you take this dot to a certain room and add another object to this room, the wall is gone. Maybe not on the first time, maybe you've got to leave the room and enter it again, but then the wall is definitely gone. And if you go to this wall that is now gone, you can witness the first Easter egg of video gaming. The revenge of a disgruntled video game programmer. When Atari released their games, the programmer of video games got a salary of about 20 to 25K a year. And they didn't get their name. Not in the manual, not in the game, not anywhere. It was an Atari game, it was not a game of a programmer. So Warren chose to hide this one very deep in there. And after that, quit. So let's take a look on how you're going to program it. Back in '77, you've got code assembled on a computer running a proprietary OS. My guess was that it was CP/M, but it wasn't back then. It's connected to a special cartridge which simulates the ROM inside the Atari. And when the software crashed, you would just see stripes top down. Why? We're going to learn later on. For debugging, a logic analyzer was used. So something leading to a special condition could be displayed. It does not need the crash, but something else could also be done. Nowadays, it's much more simple. You've got your code assembled on almost any operating system you're going to choose like. You can run your code inside a very in Stella, which is an emulator with very sophisticated debugging options. And once it works like expected, you can transfer it on a special cartridge, which simulates the ROM for you. Supercharger was the first was able to do this, and Harmony Card is the current one that you can buy. In between, there have been about 4 other cartridges, but they are not available anymore. So this is what the supercharger looks like. The data is transferred very much like it was done on the home computer back in the 80s, so with an audio-coded signal. The game developers mostly use this to plug in the audio signal into the sound card so that could create the data direct from there. This is what the debugger looks like. So you've got your source, your object code, you've got all the RAM in one view, and you've got the display of the game. It turns black and white once the new screen will be drawn, so that you can see where you are going to draw your data right now. Piracy. It was even back then an issue. In the design phase, nobody thought about it because they thought, this hardware is so sophisticated, no one ever will be able to hack it. But suddenly there was competition in the name of Activision. Activision was founded by 4 Atari programmers who decided that they wanted to have their name on the cartridge, so they had to go independent. And there was a nice talk before they did that, and this sentence was the one that really got them going. Well, Atari and otherwise. They filed a lawsuit to prohibit third-party game development, and they lost that suit. And other companies, now that the jurisdictional stuff was clear, jumped into that and really lead to a flood of game cartridges by other programmers. Some of them were really nice, but